Hi, my name is Lee Stranahan, and welcome to Modeler Essentials Part 2. In this tape, we're going to be talking about a lot of the object creation tools you use, such as those found in the Modify or Multiply menus. We'll also be talking about some advanced features, such as Booleans and spline patch modeling, and we'll be giving you some tips for creating objects quicker and easier. We've got a lot of material to cover, so let's get started right away, but let me just mention right off the top that we'll be taking for granted everything that we covered in Tape 1. We'll be taking for granted such things as the selection tools, for instance, selecting points, connecting points together, using layers, and so on. If you have any questions about some of those basic features, you might want to go back and review or watch Tape 1 of this series. All right, let's get started right away, and I want to start by talking about the Modify menu. And the Modify menu's got a lot of tools on it, but once you see there's sort of a pattern that flows through it, it's a lot easier. Now, in order to show you the Modify tools, I need to have something to modify, and so I'm just going to make a multi-segmented box. I'm going to go to the Objects menu and do that. So here we are in Modeler. We're already here for you. We'll go to Objects, Box, and I'll just drag out a 1 meter by 1 meter shape here. And let's go to our numeric options. I can see it wasn't exactly 1 meter. By the way, you can save a lot of time. I mean, there's no law that says I have to draw this out. I could just pick box and go right to numeric and enter these. So let me just enter negative 50 centimeters here. And I'm going to do it 10 segments by 10 segments by 10 segments. And the reason I'm making this box multi-segmented is this is a principle we discussed a little bit in part 1 of this series. But the more polygons you have, the more flexible something is. And the analogy I use here, it's, if you've ever seen there's fabrics out there that are made of metal. And they're actually little pieces of metal that are sewn together. Well, if you have that fabric, it's very, very flexible. It's not that the metal itself is flexible. It's that there's so many small pieces of metal that it can really sort of bend and deform properly. Well, it's the same principle in Modeler. A polygon itself really has very, very little flexibility. You cannot, if it's just one polygon, you can't smoothly bend it or anything. On the other hand, if you have dozens of polygons, then it can appear to smoothly bend because each one is moving around. And it's a principle that will come up, especially when we get into some of the deform tools a little bit later on. And that's why I've created this box with multiple segments. Normally, if we weren't going to deform this in any way, just leave it as a box. Multiple segments don't buy you anything. You're not really getting anything. But if you're using it with a feature like bones, or as I said, some of the modeler deformation tools, you need multiple segments. So we've got this multi-segmented box. Let's start to look at the Modify menu. And right up the top, we've got features such as Move, Rotate, Size, and Stretch. Now, if you're familiar with Lightwave, you'll remember Move, Rotate, Size, and Stretch because you use these in layout all the time. And we also remember the principle we talked about in Tape 1, nothing selected, so it's like everything selected. So if I do a move, it moves the whole cube. If I do a rotate, it rotates the whole cube. And it rotates it, by the way. Rotate works around whatever point you click. Let me just undo what I did there. You'll notice if I click right in the middle of the cube, I'm holding down the left mouse button and drag, it's rotating around that point. Whereas if I click off center, click over here, you notice now it's rotating around there. So the idea is that rotate rotates around whatever point you click down on. Then, of course, we have size and stretch. Now, size and stretch are actually fairly similar. The difference is that size works uniformly on all three axes. In other words, size resizes the object in X, Y, and Z all at once. And it's an important distinction between size and stretch. It's going to come up in just a couple minutes. Now, there's one thing I want you to notice here as we go through Move, Rotate, Size, and Stretch, and that's that our mouse pointer, the cursor, actually changes whether you have Move, Rotate, Size, or Stretch chosen. So if we have Move chosen, you see the cursor is this little sort of cross. If we have Rotate, it becomes these little rotating arrows. Size is a box inside a sort of dotted box. And Stretch, again, a dotted box, but it just shows you that it's non-uniform. That's the difference. Stretch lets you, as opposed to size, make it just longer or just wider. So it operates independently on X, Y, or Z axes. Now, if you see the distinction here between size and stretch, so that one works on uniform axes, size affects X, Y, and Z equally, whereas stretch affects X or Y or Z or any combination of them, but it can affect them unevenly. If you get these Move, Rotate, Size, and Stretch tools, then I want to point out that the other tools that are on the menu, you notice there's a whole bunch of other buttons here, all become very, very easy to figure out. And I want to cover a little bit more on this, but let me just give you a hint as to where we're going with this. You notice that Move is the top button in this Position section of the Modify menu. Then below that, we have the Flex section. Below that, we have the Deform section. Well, Move is to position what Shear is to flex and what Magnet is to deform. In other words, what these Shear and Magnet tools are is their way of moving parts of an object, because again, they're at the top of that, but they just affect different portions of an object. Move affects everything you have selected, whereas the other tools, Magnet and Shear, they move things, because again, they're at the top of the menu. They're doing a move function, but they only affect part of an object, and we'll show you how that works. But I want you to notice it's the same thing here. If we go to Rotate, Twist, and Vortex, all function similarly. And take a look at the cursor. For Rotate, Twist, and Vortex, they're all the same. For Move, Shear, and Magnet, they're the same. For Size, Taper 1, and Pole 1, they're the same. So these tools, as I say, once we start to get into these a little bit, you'll see that Move, Rotate, Size, and Stretch, once you get those functions, you'll get the other functions as well. Now, the way all of these flex tools work is instead of affecting the entire object, they affect from where you click, they affect either near where you click or away from where you click. And I can call this the top or bottom, although that's not strictly true, because of course you can click your mouse in any view. But basically they're affecting either near where you click or away from where you click. Let's start with Shear. Now remember, Shear is at the top of that menu, so it's a move function. And what Shear does is it actually moves either near where you click or away from where you click. And let me just show you how that functions. We'll just go to Shear, click up here, hold down the mouse and drag. And you notice it's doing a move, but it's only moving the top. It's only moving near where I click down. Now, the way we can change that, if we want to move the bottom instead, let's just undo that, is go to the numeric options. Remember, N is the keyboard shortcut for numeric. And you'll notice there's a few things that are set here, such as which axis you're picking. And in this case, I was clicking on the top here. So right now, we're really going on the Y-axis. And you see that's what's selected. Now, one thing about these numeric requesters is when you perform an operation, they remember what operation you did, and they show you the results of the last operation you performed. So because I clicked there and dragged it a little bit, it shows me that we're on the Y-axis. Now, let me skip range for 1 second. I want to talk about sense. Sense determines whether what you're picking is near where you're clicking the mouse or away from where you're clicking the mouse. You notice if I change sense to negative, and let me use keep. If I hit apply, it would actually do what we suggest here. But let me hit keep. And this means it doesn't affect the object, but it does remember those settings. So now when I click and drag, you'll notice now it's moving the bottom of the object as opposed to the top. And you get the idea here. Shear moves either from close to where you click or away from where you click. And what's the use for this? Well, one obvious use is creating italicized text out of a font that has no italics options. And let me just show you that real quickly. It's very, very easy to do. Just go to another layer down here. Hit Shift W, which is the keyboard shortcut for generate text. And let me just load up a font. And I can see, for instance, that let me just use a Hubris here. I can see that there's no italicized version. So I'll just type in some text. Hit OK. And let me just center it up real quickly. Remember the F1 key brings up that center macro. Let's go to Modify, Shear. And again, I click on the top, because the way to think of this is it's like I'm dragging you to the top or bottom. Now, it's going to remember the last setting that we have. So remember, our sense is set to negative. I could leave it there, or I could switch it. It doesn't make any difference, really. If I know it's going to move the bottom now, I just move the bottom over this way a little bit. And release. And there we go, italicized text. Now, one thing you need to watch out for is you need to make sure when you move the mouse, it's moving only the direction you want it to go. Otherwise, you can create some problems. Let me show you the wrong way to do this and sort of a quick way to fix it using numeric options. If we click and drag, I'm dragging left and right now. You notice if I move the mouse up or down, it's not only stretched me, giving it an italicized thing, but it's also put me at an angle. Now, I may or may not want it at an angle. In this case, I don't want it at an angle. And the thing that's dangerous is sometimes, let me just undo that. you can get it right where you want it, but it's tricky, you know, it's a little bit off angle. Well, there's a quick way I can fix that. If I undo my setting and then go to the numeric option for that flex there, I can see that my offset on X is negative 0.55, and my offset on Z is 0.05. Well, I don't want any offset on Z, so I'll just manually enter 0, right? Then hit apply, and you notice now it moves it in the X direction, but nothing in the Z direction. And you can actually use this to sort of manually enter settings. Again, anything you can do with the mouse, generally you can do with numeric options. In this case, because I want to eyeball it to make sure the text looks good, I use the mouse at first. But I can go in, undo it, modify my settings in numeric, and then just apply them, and it will automatically do what I say. And you'll see that, especially when we get into some of the features like bend, for instance. Just a principle there. Now, let's go back to our cube that we have now sheared. Torque. Let me just shear it back. All right, pretty even there. And let's talk about twist. Now, what shear is to move, twist is to rotate. Remember what shear did is it moves either the top or the bottom. Well, rotates the entire thing. So what twist is going to do is it's going to rotate either the top or the bottom. And that's just what it does. If we have twist chosen, we click up here and drag. You'll notice it's just rotating the top part, bringing it over, creating a different shape. Rotate it back the other way. Now, this is where you start to get into a little bit of danger when you're working with polygons, because anytime you have polygons that are not triangles and you start deforming them, you run the risk of getting polygons that aren't going to render properly. Remember the example I used before about thousands of pieces of metal that are sewn together? You can get into the same problem here. If you twist it too far, the polygons will twist. They will rotate a little bit, but they get into render problems. They will just not render properly. And the way around that is by tripling the polygons. So one thing you might want to do if you start really torquing the polygons, really twisting or bending them, changing their shape quite a bit, is use the triple function. Keyboard equivalent is Shift-T. And the triple function can be found under polygon triple. And what it does is it just turns the polygons that exist here into triangles. And I'm not going to do that for right now because I'm not done playing with this shape. But often, I'm just mentioning it right now, if you do something like this and try to render it, you might get some polygons that just won't render properly. So you'd want to use triple there. Okay, and again, let me just point out that for twist, we'll undo what we last did. Let me try to twist it back so it's normal again. Normal or as close as I can get to it. Let me bring it over a little bit here. Let me just point out that, again, we have numeric options. You can pick an angle. You can pick how far it's moving, your axis, your sense. By the way, automatic and fixed, the difference here is that automatic, it automatically figures out, remember I'm talking about the top and bottom, or near where you're clicking or away from where you're clicking. Automatic does that automatically. With fixed, you can have it affect just the part of an object that you want. So I could have it just rotate the middle, for instance. So it's a function that comes up in some cases. It's a more advanced function. But again, just to show you the basic functioning here, I typically use automatic. There are times when you use fixed, but it doesn't come up as much. Finally, let me just mention, since we're in this requester, for purposes of completeness here, ease in or ease out. What this does, instead of just twisting the whole thing at a uniform rate, it starts the twist in this case. It starts the twist a little bit slower if you have ease in, and then it picks it up. So it sort of gives you more of a gentle beginning, and then it moves a little harsher at the end. Ease out means it moves a little harsher at the, gentler at the end, and a little harsher in the middle. And this, again, is just a way of creating sort of a smoothing effect as you start to go into these functions. And you'll notice the numeric requesters for all of these. This is twist, but if we go to taper, very similar requester, a few differences, but you've got a lot of the same functions. Taper 2, same thing. All right, and bend, of course. Also, all of these have similar requesters in a lot of ways. You pick an axis, you pick a range, and a sense here. Now, let's move this back and talk about taper 1 and taper 2 for a second. Taper 1 and taper 2, people get thrown on this because they go, well, taper 1, 2, what's the difference? The difference here has to do with size and stretch. Remember, these relate to the size and stretch features. Remember, size affects all axes uniformly. Stretch affects individual axes differently. That's the difference between taper 1 and taper 2. What these are doing is, let's talk about taper 1. It's basically doing a size on either the top or bottom, near where you click or away from where you click. If we pick taper, click and drag, you notice it's making the top either bigger or move it the other way, smaller. But it's uniform. It's keeping it the same. If we use taper 2, this relates to stretch, because again, size is on the top, stretch is on the bottom. Taper 1's on top, taper 2's on the bottom. Taper 2 means I can sort of distort it so it's like, well, I went a little nuts there. But you see what it's doing? I can make it so it's sort of non-uniform. Now it's for instance, much more stretch in the x-axis than it is on the z. I'm forcing it even more here. So again, if you see the idea behind size and stretch, taper 1 and taper 2 just relate to them. Now, I've messed this box up completely, but again, for purposes of demonstration, it shows you how these tools work. Let me show you the other tools, and we'll get into some practical uses for these modify functions in a second. Let me just make another box, because I've destroyed this one beyond the point where I can bring it back safely. So let me just go to another layer here, hit box. Now, I don't have to drag anything out. If I hit numeric here, it remembers the last options we selected. So I just hit OK, hit return to make it, and there we go. There's our box. Now, you saw the way the flex tools worked, the shear, twist, taper tools. The way the deform tools work is instead of picking, again, it's like move, rotate, size, and stretch, except instead of picking either near the mouse or away from the mouse, you actually select a region. You pick a region, and then you just affect that region with either a move, rotate, size, or stretch. The way you select the region in all of these tools, and we'll start with magnet, is very simple. You pick the tool first. Let's do that. And then with the left mouse button, you drag out the region. And what I'm going to do is I'm just going to focus on this upper corner here. So notice we've got one corner chosen. This is with the left mouse button. Now, this center here, where this line is, this shows sort of, again, it's called magnet for a reason. We can click on this and drag it around, by the way. But the way this works is that polygons that are closer to that center will be affected more by the magnet tool. So what we're going to do is we're going to hold down the right mouse button over this area and drag. And as I drag, what you'll notice is that polygons are being moved, because remember, magnet's at the top, so it relates to move. They're actually being moved and pulled up. And the ones that were closer to the center are being pulled more. And let's actually go to display options. D is the keyboard shortcut. So I'll hit the D key, go to a moving solid preview up here, just because it's a little more interesting to see. And you see here we have this slightly deformed cube. Now, remember before I mentioned that you need more polygons for this tool to work properly. Let me just show you real quickly what would happen if you did not have as many segments in this cube. I'll just go to another layer and make a box. Instead of having it 10 by 10, I'll just have it 1 by 1. I'll go to the magnet tool and right mouse button drag. It's not really doing much there. And again, it's because it's like the difference between thousands of pieces of metal sewn together and one big piece of metal. It cannot deform the shape. Not much you can do with it. Now, next tool is vortex, and vortex works very similar to magnet. You draw out with the left mouse button this bounding box area, and then it acts like rotate, because it's the second one in the menu, and it will rotate the polygons. The ones closest to the center are the ones that are rotated the most. So let's see that. We'll go back over here to our good box. I'll put it on the back corner. And let's use right mouse button here. And again, you'll notice what it's going to do is it's going to do a rotate. And the ones that are closest to the middle are being rotated the most. Okay. Didn't seem like it helps the shape of the box there, but you see the idea. What it's doing is it's actually rotating these polygons. Now, once you start getting into tools like this is where tripling obviously makes a big difference. Finally, let's talk about pole, and I think you're starting to get the idea now. Pole, or just pole 1 or pole 2. Pole 1 affects all uniform axes uniformly. Pole 2 affects them differently. And these are actually doing a size. So if we go down here, here's a pole 1. You notice it's sizing polygons. And it's actually making the ones closest to where we... let me just undo that for a second. Let's click here. It's actually sizing polygons there. It's actually making it bigger. And the ones that were closest to where we had the center of this were sized bigger. You notice the polygons actually grew. Now, pole 2 is like stretch, because this is going to let us change the size ununiformly here. I'll go over to the middle, shrink it down or whatever. Now, again, we've made a pretty good mess out of this simple cube. Let's start to get into some practical uses for a few of these tools. And I want to start by showing you one just real simple practical use that comes up quite a bit. People want to know how to make terrain. People want to know how to make, just gently flowing hills or an undersea landscape or something like that. And there's absolutely nothing to it once you start to see how a couple of these tools work. So we'll start with magnet. This is basically the idea behind creating terrain is we use the magnet tool. So let's see how this works. We're going to go to an empty layer, and we're going to drag out a box, and we'll make it a perfectly flat box. So I'm going to the top view, and I'm using the comma key to back off till my grid is fairly large. Each grid square is 50 meters now, which is good, because I obviously don't want a piece of terrain that's a meter by a meter, unless I'm working in a very small scale. I mean, there's times when that might be fine, but for my purposes, I want something a little bigger. It's flat. You notice it has no depth, and I'm going to leave it that way. I'm not going to give it any depth. And the thing I have to do here is make sure I give it multi-segments. So I'm going to give it a lot of segments. Let's say 30 by 30. 30 by 30. And if we zoom in here, you'll see it's created a nice mess, sort of a mesh of polygons, or as I sometimes say, a mess of polygons. But you got a lot of polygons here in this flat shape. Now what we're going to do is, let's triple it. First off, Shift-T, because I know I'm going to be deforming this and I want it to render properly. And tripling it just turns these polygons into triangles. If we triple it again, by the way, it really doesn't have any effect. All tripling does is it, once you have basically it just takes all polygons that aren't triangles and makes them triangles. If all the polygons are triangles, triple doesn't do anything. It doesn't split it up into further polygons. So we've done that. Let me also mention one other thing about drawing out a flat piece of landscape like this. Remember from tape 1 we talked about the fact that polygons have a facing. They face one way or another. Well, anytime in this version of Modeler, 3.0 or 4000, you drag out a flat polygon, it's going to face downward, which is not the way we want our terrain facing, obviously. And you can see that is if I choose polygon and select a couple, notice they're facing down. So we don't want that. Now, one thing we could do, and just let me give you a little time-saving hint here, is, of course, we could pick all the polygons. I'm going to hold down Shift. I'm just going to lasso all of them. So they're all chosen. Then I hit F. And now you notice they're all facing upwards. Now that works. But there's a quicker and easier way to do it, and that's by selecting nothing. Remember, if nothing is selected, it's like everything is selected. So right now I have no polygons selected. That means if I hit the F key, and watch the screen here, I'm going to hit the F key, watch what happens. You're going to see the screen flash, watch. So there's just a little bit of a flash there, and then it redraws. The polygons are now facing down. Hit F again, they're now facing up. The advantage here is I don't have to wait for it to redraw the polygons. I'm saving myself, how much time here? A couple seconds. On complex objects, you save yourself 4 or 5 seconds, depending on the speed of your machine. But the thing is, scientists have proven that these few seconds add up to 8.5 years of your life. So you want to speed up the process wherever you can. And one way is, just remember, with nothing chosen, it's like everything is chosen. There's no reason to select it to do the flip. Once I know that they're, by the way, once I know that they start facing downwards, then I just make it automatically flip it upwards. Now we've got this done. Let's use the magnet tool to sort of pull up some hills. And what I'm going to do is I'm going to create a piece of landscape where our camera will start off in the center. So I just want hills all the way around the sides. And so, go to Modify, go to the magnet tool, drag this out. And again, let me just do let me actually pull it up so it's covering a little bit more of the land here. Click and drag, right mouse button, and there's a hill. Just do another shape over here, and again, pull it up a little, there's another hill. And so I'm just going around the edges and quickly kind of creating hills right around the side. And finally up this end. Actually, wait. I think down here is where I haven't drawn yet. Now, if I want to, I can kind of zoom in and work with the magnet tool on some smaller areas and do stuff like actually kind of stretch it down a little bit to create sort of valleys and stuff like that. But you see the idea. We can kind of quickly work in here to create different areas, different sort of hills and gullies and that sort of thing. Drag it down a bit. Now, one problem you're going to run into here, of course, is if you want to put, let's say, houses or something like that on the ground here, you're going to have a little bit of trouble doing it because, well, it's hard to make a house exactly correspond with where the ground is. And since you have to, when you go into layout, it starts with this bounding box. It's a little tricky. Now, this is especially true if you're laying road, for instance, a long section of road. So there's a couple tricks I've come up with for getting around that. And one of them uses a feature called set value. Now what I'm going to do is let me just back off a little bit here. And let's take a section in the middle. And I want to kind of, I'm going to draw a big bounding box. I'm still in the magnet tool, mind you. I'm going to kind of, let me just make sure we're covering the whole thing here. Yep, I'm going to kind of click and drag. So the middle is towards the ground plane here. And right now you see I've made it so the middle of the object is basically towards the ground plane. Now what I'm going to do is, and you can see that here as well. What I'm going to do is back myself off a little bit, and I'm going to pick a bunch of the polygons in the middle. Because remember, this is where I'm going to have a house or something like that. So I pick a bunch of these polygons. And what I'm going to do is use a function called set value. Now what set value does is it forces whatever you have selected to move to a certain value. What we want to do here is take these polygons that we've selected and force them to be at 0 on the y-axis, up and down. Pretty straightforward. But this will make it so instead of trying to nudge it into place and, gee, I hope this is right, this will force it down at 0. Now, is that going to give you, since we've got these polygons selected, is it going to give you a smooth transition to that point? No. It just forces it there, but hopefully it will look okay, and we'll see how it actually looks. We may need to go back in and do a little bit of polygon modification, but that's one reason why I just brought the entire middle down a little bit. Because if basically if I had the polygons that were all facing up, pick some polygons in the middle and forced them down this way, you get this dangerous hole right in the middle. We don't want that, so I kind of pulled them down towards the center. Now if I do a set value, it'll be a little smoother. So we got these polygons chosen. Let's go to the Tools menu, Set Value. You pick the axis, you pick the value. I'm actually going to use -0.001. And this will put the ground plane actually 1 millimeter below 0. And the reason I'm going to do that is when you load an object such as a house or a road or something like that, it loads, if you load the road object that comes in the landscape directory, for instance, the road object loads in at 0. And if my ground is also at 0, those two things are going to share the same plane. They're going to be in the same area. And that means the computer's going to have trouble rendering it. It's not going to know whether it should render the road or the ground, so it will render this ugly mixture of both. By putting the ground at -1 millimeter, when the road object loads in, it will be right on top of the ground, which is quite handy because it means I don't have to push it up or anything like that. So that's all I'm doing here is putting it 1 millimeter below, so when I load in other things like houses or roads, it'll work properly. So we set it to there, hit OK, and it forces these middle polygons here to be perfectly flat. Forces them right here in the middle. Now, let's just do a quick save on this. And before I save it, I'm going to give it a surface name. So I can either do Q, which is the keyboard shortcut, or go to Polygon Surface, either one. Q, and I'll give this a name like ground. Hit Apply. And now just save the object. We'll also with the name ground. Shift Q will bring us into layout. And if we load this up, and let's load up just a house. From the railroad directory, there are these little branch line stations that I like because they're just little house objects. And we'll select our camera. With move chosen, we do a reset, which puts our camera right in the middle. But there's a house. You notice it's on a flat piece of ground. We can see polygons kind of pushing up this way, but that's all right. Again, we'd have trouble positioning this house if we weren't on flat ground. It's possible, but I'm just trying to avoid that hassle. And this looks like it'll work. Now again, it's not going to be very exciting. Let's just do a quick low-res preview here. Since we haven't really set any surface attributes or anything, you're going to see this house on this mesh of white polygons, which isn't exactly thrilling, but you'll certainly get the idea here. And we could quickly go in and apply a surface like a fractal noise surface or something like that to make it look better. Here's the way the picture looks just with what we've set up so far. And here's the way it looks just by adding a different surface. What we've done here is we've taken the ground plane, smoothed it, added a little bit of texture to it, and just changed the color in the background. Again, by changing surfaces even more, we could make this obviously a much better looking picture. But since this is a modeler tape and not a surfaces tape, we don't want to spend too much time on that. All right, let's head back into Modeler. Let me clear out the scene before I leave here, actually. Head back into Modeler. And let's talk about using another modify option here, Bend. And we're going to use Bend with text here. Again, this doesn't relate to the move, rotate, size, stretch stuff that we saw. Let me show you how Bend works. And again, we'll use it to create a fairly common thing that you see all the time in logos, which is text moving along a curved path. Now, there's two tricks to it. Let's just get the text created first. So again, we will bring up text here. And we'll type in just welcome to our show. Exclamation point. Okay. And again, I'm using a fairly long piece of text. There it is. Now, what I'm going to do is let me first, before I do anything else, just extrude this first. So I go to multiply, extrude, pick an appropriate depth for it, hit return to do a make. And again, it's a fairly big piece of text, so it takes a little while for it to extrude there. And let's also do a center. F1 will center it up here. Now, what I'm going to do is I'm going to take this text and bend it so it's going along at an angle, and then I'm going to want to move it along a curved path. And you'll see this is very, very easy. The first option we need to use here in Modeler, though, is Bend. And what we'll do is we'll just go to Modify, Bend, and then we will click and drag on one edge. We're going to click on this edge. And the way to think of it is you've got this long thing. We got this long piece of text. What we want to do is we move it along, we want to bend it, so it's like we're grabbing it from one corner and pulling that corner down. That's the way we're thinking of it. So this is the corner we want to grab it from. We click and drag. This is all left mouse. And again, I want to line it up here so it's straight, but again, we saw this a little bit earlier. I don't need to worry about it too much. You just hit A to fit it in. So it's bent along the corner here. You notice it's off angle on this side. I'm not going to worry about that because I can undo, then go to numeric options, and it will show me that my angle was 75 degrees. But you'll see right here, see direction was negative 179 point something something something. That 179 point something 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 means it's not moving at exactly 45 or 90 or 180 degrees. And the problem with that is when our angle is offset like that, even just, you see it's 179 point something, it's close to 180. But since it's not exactly 180, it's moving off kilter there a little bit. So we'll just change it to negative 180. And the center we will set to exactly 0, 0, 0. And we'll leave it at a 75 degree angle. Let's apply this. You can see why I did the undo first. Now it's moving along at that angle. That's fine. And also it's perfectly on kilter here. So what we did is we're just changing direction within that requester, and that makes it a little easier. Now I've got the text bent now properly. What I want to do is, since it's bent one way, I want to rotate it so it's actually, the bend is right in the middle, so it's sort of evenly distributed over the center there. And what we're going to do is obviously use the modify rotate function. Now I'm not going to go in and try to do this by hand. I'm going to be lazy here and do the right thing, which is use rotate numerically. I just pick the rotate option, hit numeric, and since we did an 80-degree angle of bend. What we need to do here is on the z-axis. In other words, it's pushing through here, so it's sort of moving through the center. We need to give it a negative 40-degree angle, because an 80-degree bend, negative 40-degree angle. Same center as we had set for when we did the bend function. Remember when we used bend, our center was 0, 0, 0. What we have here is a nice evenly distributed curve now. And now I'm just going to center it back up. You notice it's off. Remember the pivot point here we discussed in tape 1. Let me just hit F1 again to bring it back to the middle of the pivot point. So this is nice and evenly distributed. So if you bend something 90 degrees, you rotate it back 45 and it will work properly. Now one thing that we're going to do here is I want to offset the pivot point. I've got it centered right now. But if I want to make it look as though this text is moving along the curved path, it's really pretty easy to do. What we're going to do is we're going to offset the pivot point. Rather than keep it in the middle of the object, we're going to have the object set away from it. This way when we rotate the object, it's rotating since it's rotating around the pivot point, it'll look like it's moving around a curved path. Now, there's a couple different ways we can do this. One is just to eyeball it. Just back off here a little bit. And what I want to picture is a large circle of which this is one part. And I need to center that. So one way I could do it is I can just eyeball it here. Another way is to actually make a circle. And let me do that. Just go to another layer, have the text layer visible in the background, and then drag out a disk. Now when I draw the disk here, what I'm doing is I want something that the welcome to our show fits right along the side. And this way it will give me an idea when I center up that disk where to put the welcome to our show. This is one way to do this. So let's just drag out the disk shape. Back ourselves off a little bit. And I want it at a point where it's fairly even. It looks pretty good. I've got it, like I said, I've eyeballed it into place. Let me use my numeric options here to go in and set an equal radii. So if I've got 8.5 for x, I want 8.5 for y. And I want my center to be 0, 0, 0. Now, what I'm going to do is switch our layers. So I want the layer that's in the active right now to be inactive, the layer that's inactive to be active. Quick way to do that, if you remember from tape 1, is the quote key. That switches our layers quickly. And now I just pick Modify Move, and I move the object kind of up here so it's resting along the edge. And this gives me a pretty good idea. This is how far it should be offset from this pivot point. Now, I just want to make sure it's centered properly on the x-axis. So I'm going to do that F2 center 1D macro for x. And looks pretty good. Now let me just quickly sort of save the text object. I'll call it bent text. All right, now if we load up the object into layout, all we need to do is choose the object, rotate. In this case, we're rotating around bank, so I turn off everything but bank. And what you'll see is it's rotating. Since it's rotating around the pivot point, let's just keyframe it. Here at 0, then let's say at frame 90. Put it over here. And when we make a preview here, let's set our last frame to frame 90. Just make a wireframe preview. And we'll end up with text that looks like it's rotating, moving in a circular path there. All we're really doing is just rotating it around an offset pivot point, but it looks like it's moving in a nice curved path there. So let's take a look at that done wireframe preview here. And you get the idea how this works. Now obviously we could use this not only to bend it the way we've bent it left to right, but let's say we wanted to do something like the Universal Studios logo, where you've got a piece of text that's bent back towards you and it's flying around a planet or something like that. A popular look, I hear. Well, you can create that pretty easily. Just bend it in a different direction. Rather than bending it down, bend it towards you, for instance. And again, the same rules we talked about rotation and about setting it up so that the pivot point is right. All of that stuff works. All right, we've seen a few different uses for the modify tool. Now we want to start to talk about an entirely different tool here. It's the sketch tool. And this will actually be helpful for a number of things that we'll create. So let's take a look at that. Let's just clear out everything we've got here using the new function to get rid of everything. And we showed you in tape 1 how you can create polygons or curves by just drawing out points and then connecting them using either the P function or the control P function that connects into an open curve, or control O, which makes them a closed curve. Well, there's another way of doing this without actually drawing the points initially, and that's by using the sketch function. And before I show you sketch, though, since I've got a shape up here, let me show you one last modify tool that we're going to use with sketch, and that's the drag tool. Drag tool is very, very handy, and real quickly what it does is it's a much better way of moving points around. It's a move function, basically, but it's a much faster way of doing it than you could do without having the drag tool. All you do is you choose drag, click, and drag. There you go. Fairly straightforward. And you see it's especially handy when you're dealing with curved shapes. Now let's talk about sketch. What sketch does, instead of you drawing out the individual points, sketch mode lets you sketch a shape out. So let's go to an empty layer, and we find sketch under the objects menu down at the bottom here under the box, ball, disc, and cone option. We sketch out what we want. We hit make or return or draw it with the right mouse button, and there we go. What it's doing is it's approximating the shape that we drew. Now, you have numeric options for sketch, and one of the basic numeric options chooses whether you're drawing an open curve or a closed polygon. You notice let me just undo what we did here. If I go to numeric and pick polygon, now I can draw out something like this, hit make, and it approximates the shape, but it actually makes it a closed figure. So I can do really bad text like this, but obviously you can use this to create a number of shapes. And again, this is actually a fully closed polygon. Now, we usually use it with curve, though, because usually we use this for object creation. The one other option here that you have in the numeric one shows you which plane you're moving it in. In other words, you're drawing this, let's say, from the top view here. Well, it automatically puts it to 0. If, on the other hand, I go to the numeric option, I can choose another plane, such as, -1. And what this means is the next thing that I draw here, you see it's drawn at -1 meters, because that's what we had selected here, 1 meter for our units. So it drew it at a plane of -1 meter this way. So in other words, since we're drawing on the front face, it knows, okay, draw it normally there, but it's got to figure out where to position it, and you can select that numerically. Now, a couple things about sketch. Let me go back to curve here, show you this, but we'll just clear off everything here. We'll go back to curve. We'll set our plane back to 1. A couple of interesting things about it. One is it knows how fast you draw. If you draw quickly, and this is again a curve shape, you'll notice it's put 5 control points. 1, 2, 3, 4, 5. Now, on the other hand, if I draw a similar shape slowly, it's going to put more points in because there's sort of more detail to the drawing. So the slower you draw, the more control points it ends up putting in a shape. Same shape drawn slowly, a lot more control points. This will even work in different parts of an object. If you draw some parts slow and some parts quickly, even in the same sketch, it will give more control points, more detail to the parts you draw slowly than what you draw quickly here. Now, we have a number of uses for this, even with the curve. And you remember from tape 1, the curves don't actually render. They're just there to help us create shapes. But what I want to show you before we actually use these for modeling is show you a couple tools that use these. Now, remember, we've already shown you extrude here a little bit. We've already done an extrusion on this tape. We talked about it in part 1 of this series. Let's talk about a couple of other extrude options. And just to do a quick recap, we've already seen it once, but if we take a shape, I'm going to drag out a disk here, and I'm going to make it a sort of semicircle by picking the points on the bottom and cutting them away. So you have a semicircle shape here. What an extrude does, extrude pushes it off into the distance. It takes this 2-dimensional shape and gives it depth, in other words, 3 dimensions, by pushing it off into the background. That's extrude. Now, there's another type of extrusion you can do called rail extrusion, and it works with a path usually best drawn by using sketch mode. Now, of course, you could draw it anyway, but as you can see, sketch mode is a quick, easy way to draw shapes like this. So here's what we're going to do. Let's undo what we did there on this shape. So we'll bring it back to 2 dimensions. What we want to do here, let's actually move this down a little bit so it's more centered. Quick way is the F1 key, or I could move it manually, but F1's quicker. So this is centered up. And what we're going to do is let's go to layer 3, make that our active layer. And this is where we're going to draw our sketch path. With rail extrude, you use 2 different layers, one for the sketch path and one for the object you want to move along that path. So let's make layer 2 visible in the background or inactive layer by clicking on its bottom button. And now from here, if we go to the top view, let's go to sketch and sketch out the path that we want this object to follow. Just click and drag. I'll give it a curve here. And back down this way. So it's creating the sketch path. And now what we want to do is the shape that we want to follow the sketch path. We need the sketch path in the inactive layer. And we need the shape that we want to follow that path in the active layer. So the quick way to switch layers, don't forget, it's the quote key, which we do. And now let's just go to multiply, rail extrude, and I'm going to leave it to automatic, and it is oriented. It's lined up with the front of it. So we hit OK, and you'll notice it follows the shape along here. Just put that in. You notice that's following the shape. Now, obviously, rail extrude is pretty darn handy for a lot of things, and you'll see a use for that later when we go and just make an urn or something like that. One thing I want you to notice, though, is we had some options that we bypassed. I left it to automatic. Let's talk about those other options briefly, though. We undo what we did here. Click on rail extrude again. And you notice you have uniform lengths or uniform knots. Now, both of these lengths and knots force you to a certain number of segments. The difference is that lengths will put those segments an even space apart, whereas knots will put more, for instance, in the curves, because that's what it should do. It should have more in the curves and less in the straightaways. And so if we take a look at the difference here, lengths, we'll just leave it to 20. You'll notice it's, again, nice and even here, but the curves, there's only one length between here and here. Now, on the other hand, let's undo that and use knots. And what you'll see is it puts more segments along the curves here because it needs more segments. Both of them end up, though, with giving you 20 segments. Now, I generally leave it to automatic, and the only other thing in the requester there is the oriented button at the bottom, which is an on-off button. Now, if we were to create, instead of one sketch path in the background layer, 2 sketch paths, you end up with what's called multiple rail extrude. And let me just redraw our sketch paths here to give you another example of the way you'd use that. Using sketch. One up this way. We'll make that one. Then one up this way. We'll make that. Now again, we use the quote key to flip our layers. So the rails are in the background layer, the object's in the foreground. Multiply, rail extrude, and automatically comes up with multiple rail. And again, we have a choice between lengths or knots, and automatic, we will just leave it to automatic so it does this properly. And there you go. You notice how it's following both the shapes of the rails, so since they were stretching out, it's actually growing the shape there. And if we had a little hump or something like that in the middle, it would work that way too. Now, one way, again, there's some practical uses for this. Multiple rail extrude, for instance, can often be used to create more organic shapes by having 2 or 3 or more rails that move along together. And then you just have the object, let's say you're making a tree branch, for instance. You could have a basic shape that's the tree branch and have it follow along with those rails. Now, there's another one that's sort of closely related, I think, in theory, to what you're doing here with rail extrude, and that's called path extrude. And the way path extrude works, it works with a motion path. So to show you that, what we're going to do is, let's say we wanted to create an animation of a car going through a tunnel. Well, we could pretty easily do that with path extrude. But to do this, we need to create a motion path, and to do that, we need to go into Lightwave layout. So let's do that. Let's exit out of here. Clear out our scene. And load up an object. We will just load up from the vehicles directory, the Porsche. And again, this is a sort of different way to think about modeling. Rather than making the tunnel first, we'll set up the motion path, then go back and create the tunnel. So here's what we'll do. We'll set up a motion path where the Porsche starts, say, here at frame 0. Let's make this a 150 frame scene. And so at frame 150, I want the Porsche to be, say, up here. Go to frame 150, move the Porsche up here, and keyframe it. Then at frame, let's say 70, moving the car out this direction, make the keyframe. And so you can see the Porsche is moving along a path that goes like this. Now, one thing you'll notice if we get into the Porsche a little bit, and I'm even just going to make a bounding box preview, but you'll see the Porsche is doing a pretty spectacular feat of driving where it's always staying the same direction and yet doing this like parallel parking move where it just starts to move sideways on its own. Not a bad trick. We're going to leave it like that, though. What we're going to do is we're going to use the Align to Path option. In 3.0 and 4000, this will make the object actually align to the motion path. So rather than kind of just shifting out like it's sort of moving on ice, we go to Motion Graph, click on Align to Path, and this way you'll notice the object actually aligns to the path as it curves around there. Better way of doing it. Now, so far so good. We've got the path for the car. Let's make the tunnel. The way we do this is really pretty straightforward. We've got the motion path set up. We're happy with it. Let's just make the object first by saving the motion itself. To do this, we go to the motion graph again, and we're doing this for the car. So we make sure you have the car selected as your object. Go to motion graph. Then at the top of this requester, we have clear load and save motion. And we obviously want to save this. All right, and we will just call this car motion. Hit OK. Hit use motion. And our work here in layout is done. We've set up a simple motion for the car. Now let's go into Modeler and make the object. Go to a fresh layer here. Okay, now again, one of the things that's going to be important here, obviously, is that the tunnel be bigger than the car. So what we're going to do is for the tunnel shape, again, we're just going to use a disc that we're going to cut one part off of. Very similar to the shape we actually used last time. So let's just pull ourselves out here so our grid is fairly big. Each one of these is 5 meters, which is pretty large. And so now we've got a tunnel that's about 15 feet high, 30 feet across. Let's make it a little bigger than that even. That'll work. Something like that. Now what we want to do is make this flat shape. And maybe I want a few more. Let me just undo it because I can see it's only doing 16 sides around. Let me just go to my numeric option and enter 24 for sides, just so it's a little rounder. Now again, we pick the bottom points, cut them away. There we go. Now, here's our basic tunnel shape. We need it to follow the same path that the car is going on, though. And so to do this, we're going to use path extrude. Very, very similar to rail extrude in that it's doing an extrusion, but not necessarily straight back. With path extrude, though, it needs to pick a motion path, and it will move it along there. So let's just take our shape here. We'll go to the multiply menu, path extrude, pick a car motion, and it will come up and ask us, see it says first 150, first 1, last 150. And that, of course, relates to the number of frames that we had. We had first frame of our animation was 1, last frame was 150, so it knows that. It automatically picks up on that. And the next thing is step down here. Step means frame step, and it means how many segments will you have. If we give it a frame step of 1, it will give it 1 segment for each frame of the animation. So there'll be 150 segments, which is probably overkill. Let me set 5. That means it'll only pick every 5th frame and see how that works. It may or may not work great, but let's give it a shot. Let's try 5, hit OK. That actually doesn't look too badly. Doesn't look too bad there. You notice what it's doing is it's following the shape. Now, because we just did an align to path, which is an easy way to do this, you'll notice that it follows the shape, but it doesn't rotate at all here. So our tunnel at the end is a little bit messed up. Now let's see what happens if instead of taking the lazy way out, by the way, generally remember I'm in favor of the lazy way out, but in this case, because we didn't rotate it all, you'll notice we used a line to path, it does not rotate the end of the tunnel here. So let's go back into layout and see the difference. Let's turn off a line to path. And instead, let's go to the last frame, and we want it rotated just on heading here. Let's hit center so we can see it. And having those visible motion paths is pretty handy because it means I can line it up where it's coming from. So there, the angle at the last frame. Then we go to frame 70. Let's center that. And here we want it kind of like that, I suppose. Create a keyframe there. And let's take a look now. This is without a line path. Just take a quick preview. Well, it's not exactly perfect here because it's still rotating wrong at the beginning. You notice at the very beginning here it's rotating straight ahead. So we need to rotate this a little bit so it's angling in. And let's just take a look at that. It's not perfect. You see that a line to path worked a little better for making the car look like it's actually moving along with it. But this is working, you know, okay. See how it looks at the end. And this will make a difference in our motion path. So let's save this motion path now. Here's the way it looks. The car doesn't look that great. But the angles are a little bit better. So we'll go to motion graph, save this as car motion 2. Use motion, go back in. And let's just start fresh here. So let's just start with just that one segment. Rather than redrawing it, I'll just pick one polygon. Here. And cut that out. And then delete everything else. Let me do a Z. Z is the keyboard shortcut for delete. And then just paste back in that one polygon. So now we're just starting fresh. This is rather than having to redraw it. I can just pick one polygon, cut it. When you do a delete with the Z key, remember that does not put it into the buffer. It just gets rid of it completely. So, gotten rid of that. Let's go to multiply, path extrude, car motion 2. And again, we'll leave the same settings we had last time. And you'll see it does a much better job of actually following the shape, because we've got the rotation in there that's following the shape properly. Now, I point this up because there's actually a way you can use this. What's the better motion path for doing modeling with? Obviously car motion 2, where the car is rotated properly. What was the more realistic motion for the car? Obviously the one where it's doing a line to path. Hey, we've got them both saved. Coincidence? I think not. So this will work. We will be able to use one to create the tunnel shape, then the other one for the car motion. And this is a handy way to do this. Now, the problem is, and it's a subtle problem here, here's our tunnel shape. Let's save this. We'll give it a different surface name. Q key brings up surfaces here, so we'll call this tunnel. We'll save the object as tunnel. And we will exit back here, and let's load up our tunnel and start to witness some of the beauty of 3D animation. And there's only one problem here. Let's also go to the car real quickly and load for a motion for it, car motion 1, which is the same thing but without the rotation, and give it an align to path. Okay. So let's go in here and make a quick quick wireframe preview. And you see there's the tunnel and the car will be going through it. There's only one problem, is that this tunnel is not a tunnel at all. It's a giant, basically solid piece of nothing right now. It's not a tunnel in any way, shape, or form. If we want it to be a tunnel, this is not the way to do it. However, when we get into booleans a little bit later, you'll see that this is the basis of a pretty decent tunnel object for us. But this is conforming to the path. But right now, the important thing to note is the car is actually moving through this solid thing. It's going to be completely vanished here. It's not going to show up at all. So let's take a look at the way the preview looks, and you'll see it is moving through the tunnel nicely. And one thing you'll notice is that the very end here, it seems to be doing this little flash forward. And that's a problem with align to path. It's pretty easily overcome. If you look at the Lightwave Essentials tape in this series, we talk about align to path a little bit. Now again, the thing here is this isn't actually a tunnel. It's a solid tunnel-shaped thing, but the car is moving along it very well. Let's talk about one other feature here that relates, again, to me, to extrude path and extrude along rails, and that's the clone feature. Let's just do a quick recap. We talked about clone in tape 1. Let's just do a quick recap here and talk about a couple features we did not really get into. And here's an example. Let me just take a disc shape. Pull it out. And go to the clone option under multiply. Now, we set a number of clones here, such as, let's set just 9. And we can do things, as we saw in tape 1, such as offsetting it, where if we offset each one of these, for instance, 1 meter in the x direction, it will now make a total of 10 objects, the first one and 9 clones, and each one will be offset by 1 meter in x. So we've created a whole bunch of things along here. If you're creating a ladder, for instance, or something like that, where you need a whole bunch of similar shaped objects evenly spaced, this is a good way to do it. Now, another thing you can do with clone is offset it not only in one dimension, such as x, but in 2 at a time, such as x and y. Let's take a look at that. We'll just undo what we've done here. Go back to clone. Set it 1 meter in x, 1 meter in y. And now it's going to take each clone and not only offset it forward 1, but also up 1. So again, another use for clone here. Now, one thing that's often handy, you can see the idea of it using with offsets, is that you can clone things by using rotate. And this, for instance, is very handy if you're creating something like the spokes on the wheel of a bicycle. What you're doing now is you're not really offsetting it, but you're taking each one and giving it a rotation. And so here's what we'll do to do that. We'll undo what we just did. We will take the disc shape here and move it off a little bit. I don't want it exactly on this 0 point. I want it up above somewhat. And let me center it left to right. So to do that, we use x-axis center. So we go to multiply, pick clone. And now what we're going to do here is instead of doing a offset, we'll set these to 0, 0. What we'll do is we will do a rotation. And what this means is each copy, instead of being moved, now it will be moved, in fact, by the way, but instead of moving uniformly x, y, or z, it's actually being rotated. And it's being rotated around the center point that we've set here, which is 0, 0, 0. And so since this shape right here is offset from the 0, 0, 0 point, what that means is that each cloned version will be around a little bit, and this will end up, like I say, like spokes or points of time on a clock or something like that. Now, if we want to do a full 360 degrees of rotation, and we're making 9 clones, well, obviously, 360, we end up with 10 objects. So each one should be offset by about 36 degrees. This is dumb guy math. If you can't do this, you're in more trouble than this tape can help you through. All we're doing is 360 degrees, 10 objects, 36 degrees. Pretty straightforward. So let's set that up. Let's go back to clone. You see, since I hit cancel there before, it ignored what I did in offset. I changed it to 0 before, but it ignored that. So let's set it, and since we've got it set here, we want rotating around the z-axis 36 degrees. And again, the way I know that is just if I rotate it, so you pick whatever axis you need here. Since the object is facing up like this, the z-axis, this way each one's going to rotate like that. Remember, z-axis is forward and backward into the screen. 36 degrees of rotation, we hit OK, and there we go. Now, if we pick the wrong axis of rotation, it would just rotate differently. But this is pretty much what we wanted here, and this worked real well. And obviously, if you wanted to do just half of that, you'd figure out what it would be over 180 degrees or something like that. Also, if we had the object in too close, let me undo what we just did and move it down a little bit here. We're going to do a very similar thing. We'll do a clone. But you notice because the object was set right here, since there was no offset whatsoever, it didn't move it that far. So sometimes you'll need to undo your clone, move the object up, then redo it for that to work. Now, another option you've got is the scale option. And now it's important to note, by the way, that you can use all of these in conjunction. You could use rotate and offset at the same time, and you could also throw in scale. We'll show you scale in a second. Let me just show you how to use, for instance, rotate and offset at the same time. let me move this up a little bit more and automatically center it on X. Again, using that center 1D macro. Then we're going to go to multiply clone, and I'm going to want it to do 36 degrees of Z rotation, but also I'm going to have it move forward on the Z axis into the negative Z plane. And what I'll do is I'll have each one go 1 meter. So let's just go to clone, Z, -1. What this means is that each rotated one, so instead of just rotating, will be rotated and out a little bit. And so what we end up with is this shape, sort of a helix type shape here, where they kind of move off into the distance here. And you could also obviously use this to create spiral stairs or any number of objects there. Now, this is just to show you can use 2 of these at once. Also, of course, if we wanted to, we could set it an offset in both X, Y, and Z all at the same time. If you want to really confuse yourself, just set all the options and see what happens. You want to use this in a controlled way. Be aware of what you're trying to do and set up things one at a time. Until you really get a handle on this, it's pretty easy, like I say, to set things wrong and just go, hey, I've destroyed my object, and that's not nearly as fun as it sounds. So let's add in, let's turn off offset, let's turn off rotate, and just show you scale here. We'll undo this. Offset to 0. Rotate to 0. And let's offset, if we just scale it, by the way, and don't give it any offset or rotation, it's going to make little tinier versions in the same spot, so that's no fun. Let's give it some offset in X. And we'll have it change scale on the Y-axis. So it will get shorter. Everyone will get shorter. And I will put 0.5. And what that means is the first clone will be half as tall as the original object. The second clone will be half as tall as the first clone, so on and so forth. So it will really shrink very, very quickly here. Each one is half the size. And again, you can use this for a number of things, stairs or steps, that sort of thing. Now, if we set it to a smaller degree, just go to clone here, and save it like 0.9. Now each one is a little bit smaller than the last one, so you get sort of a better idea on this. And again, a number of uses for this, such as if you're doing a bridge or something like that, a suspension bridge, you need the pylons along the way to get bigger or smaller, you can create it like that. Now, that's some options for clone, but you also have clone along rails or clone along paths. And these can, again, be very, very handy. Let's say we got that tunnel and we want there to be pylons going along the inside of the tunnel. Well, there's 2 ways we could do it. One using a sketch path, one using the motion path that we've already created. Let's just show you the sketch very quickly here, because it is pretty straightforward the way it works. Let's undo the last clone we did. Let's move the object down a little bit. And again, because it's a rail function here, we're going to use 2 layers. So we'll go to another layer, make the object visible in the background, draw our sketch path out. Let's move it back this way. Switch our layers so the rail's in the background and the object's in the foreground. Quote key is the best way to do it. Then under multiply, we will use rail clone. And 20, all 20 means is that it's going to put 20 of these little discs, 20 of these little pylon shapes along this path. If we do automatic, these will all be connected. So let's go with uniform here. And you notice by having lengths here, they're nice and evenly spaced. With clone, lengths is generally what you want to do. Otherwise, if we were to do it with knots, it's going to put them closer together on the curves, which tends to be a design error. Although, there are reasons you might want to do that. Again, in my case here, putting pylons along the tunnel, I want them evenly spaced, but that's not always the case. Finally, let's just show you, for instance, that automatic. There you go. They all touch. Now let's use the motion path option here. What we're going to do is I'm going to want the pylons to move so that there's one on either side of the road, and they move along the side of the tunnel here. So what I need to do is I need to set up the pylons properly. Let's do that by picking just as the active layer the pylon itself, and then finding our tunnel. And I just want to size it here, find the tunnel in the background, So the pylons are kind of along either side. Here's one. And then I'm just going to quickly kind of use the mirror function. To get it roughly even on the other side. Okay, so far so good. Let's get rid of that background layer by just reselecting the main pylon layer. Go to multiply. We're going to use path clone. We'll pick car motion 2. And again, first, last, and step. If we use this frame step, it's going to put it every 5th frame. So let's actually make it every. Let's give it a step of 10. This way we'll end up with 15 sets of pylons, a total of 30 pylons. 15 sets of these pairs. And there it is. And you'll notice, again, if we look at this in relationship to the tunnel, okay, we're moving along with it. It's fairly close. It's not exactly perfect. It's fairly close. You'll notice in some cases here, you might need to adjust things a little bit, and that's okay. We'll just adjust it a little bit. A lot of it depends on where the original object you're starting begins on. Now, this is a much quicker way to do something like this than going through and trying to do it by hand. So let's just use the move function and line it up this way. Again, not exactly perfect there because our center wasn't exactly the same, but fairly close. Now, let's just leave that. Let's leave that where it is for right now. Now, you've seen a couple functions. We've made pylons. We've made the sort of inner thing. Again, remember that we really don't have a tunnel so far. We've just got the shape of a tunnel. And this will bring us into our next section. I want to talk about another very important feature in 3.0 and 4000 Modeler. That's the Boolean function. So I'm going to later call up the tunnel here, and I'm going to call up the pylons as well. For right now, though, let's just save the pylons. We'll give them a different surface name. And save it as a separate object. Remember, only the foreground layer will be saved. Now, the way the Boolean functions work is they're similar in a way to the rail functions we've seen, in that the Boolean functions work with 2 different layers. You need 2 layers free. So I've saved the tunnel part, I've saved the pylons. Let me clear out everything with a new, Shift-N for new. And let me just give you a real simple explanation of the way Booleans work here. I'm going to make 2 objects. I'm going to make a sphere. Put that in one layer. I'm going to go to layer 2, make the sphere visible in the background, and I'm going to make a disk. And the disk is going right through the sphere. Now let me also hit the D key for display options and set up my preview as a moving solid so we actually see stuff up here. Now, the way the Boolean features work is they do operations between the 2 different layers. They either add, subtract, or in some way combine the 2 layers. Now, the layer that is our active layer, our foreground layer, is the main one. The one that's the inactive layer, and we're going to do a subtract here at first, is what's going to be subtracted or pulled out from our active layer. So let's switch our layers up using the quote key. You see the sphere is our active layer, the disk is our inactive layer, and it goes right through the sphere. Then we will go to Tools, Boolean, or keyboard shortcut Shift-B for Boolean. And you see we have 4 major Boolean operations here: union, intersect, subtract, and add. And the one you tend to use most often is subtract, although there certainly are some uses for other ones, and particularly union and intersect. But subtract, pretty straightforward. What it's going to do is it's going to subtract the inactive layer from the active. And when we do this, it ends up pulling the disk out, and you see we've got a nice clean hole right through the sphere. Now, you'll notice that we can still see the disk, though. This sometimes throws people. We can still see the disk, of course, because it's on an inactive layer that's still selected. If we get rid of the inactive layer just by reselecting our active layer, let me click on layer 1 again. You see the disk isn't really there. It just doesn't get rid of it. It's still on layer 2, unaltered. But we can still see it in black because it does not automatically turn off the inactive layer when you do a Boolean. So here's a subtract, fairly simple operation. Let me just undo that for a second to go back to our regular sphere and show you one other just quick use for subtract so you see the idea. In this case, we pulled the disk straight through the sphere. Let's do another one where we don't actually completely remove it, where we just take a chunk out of it. And the example I use here is a jog shuttle wheel on a VTR. The wheel itself is pretty straightforward. That's a disc. The trick is getting that thumb notch. And with booleans, it's no trick at all. It's very easy. Let's just go to layer 3. All right, so let's drag out a disc here. And just pull it out here. You notice I'm not worrying about size. This is a 1 meter jog shuttle wheel. Normally you'd never do that, but I'm not worried about size for this demonstration. I'm really big on sizing objects properly, though, in general. Just give it 48 sides here. So here's our basic shape. Here's the wheel itself. Go to another layer, make the wheel visible in the background. And now I'm going to drag a sphere that goes part way in, but not all the way in. I just want to be able to take a chunk out of it. And since the sphere only goes part way into the disk, we switch our layers, that quote key again. You can see how the quote key itself can save 3 years of your life. So let's just do a Boolean, Shift B, subtract, and it's going to subtract the inactive layer from the active one, which will cut a chunk. Again, you'll still see the sphere, but it's not really there. It's just in the inactive layer. You'll see what it did was it took a nice chunk out of the wheel there. So you don't have to go entirely through the object. You can just go part way through. Now, you can see how using subtract, we can get that tunnel shape that we've created already and actually make a tunnel. The first trick will just be actually creating a mountain type entity, and that's not really that difficult. Let's do that first. But in order to do that and size it properly, it would help to see the tunnel. So let's go down here to layer 8, load up the tunnel itself. We'll go to layer 7, view the tunnel in the background. And now just make a mountain type shape. Again, we can use there's any number of ways we can do it. What I'm going to do is make a ball. And notice I'm leaving it so the edges of the tunnel kind of stick out a little bit here. And now I'm going to, under numeric options under ball, give it more sides and more segments. I'll go like 64 by 32. And what I'm going to do then is I'm going to cut away the bottom part of the sphere completely here. So I just pick all these polygons along the bottom. A whole bunch of ways I could do this, volume, polygon, any number of ways. I'll just quickly grab all the polygons here, cut those out. I'm just taking a large chunk out of this. And now this is what we would call a very even sort of mountain here. And again, just quickly, there's a whole bunch of tricks I can use here. One is tools we've already seen, such as go in and run a magnet on it real quickly to just start to mess things up a little bit. Just use this to deform it a bit. Another tool that really helps a lot, even when you're using just general ground, is a tool called jitter. And what jitter will do is it will take the polygons and kind of move them in a random fashion. Now, jitter, to get to it, it's on the Tools menu, right here, jitter, or the Shift-J keys, the keyboard shortcut, Shift-J. And by going to jitter, whatever we give it for numbers here, 1 by 1 by 1 meter in this case, is the sort of constraint. That's how much it will move it at a maximum. 1 by 1 by 1 meter, since each one of these squares is 10 meters, might produce a bad result. Let's just see what happens. That actually wasn't too bad. It's a little extreme. You see, it's really messed it up, though. It's jittered the heck out of it. Let's undo that and use a smaller number for jitter. Let's use 0.3 by 0.3 by 0.3. And what you'll see is it creates sort of a randomness. It throws the polygons around a bit. But, you know, it didn't do it as crazily as it did it before. And then we could just use the combination of some of the modified tools, magnet, sizing, stretching, to get this into a mountain shape. For our purposes here, I'm just going to leave it the way it is. It'll still look a little, weird. It's not exactly perfect or anything, but it will give you the general idea. And again, you've seen the way to work that now. Now, there's one other thing I want to do here, and it's, of course, because as soon as I start deforming things like this, I could have problems with triple polygons. One thing we might want to do if we want to save polygons, before we said just a sort of general blanket, do triple stuff. That's true, especially if you're doing any tools like displacement mapping or bones. And something like this, where we know we're not going to be doing much else with the model now, what we can do is we can use the non-planar option in statistics. We pick polygon here, hit W to bring up the statistics screen, and then below at the bottom here it says non-planar. If you hit plus, it will go through and select any polygons that are non-planar. And then you can just triple Shift-T those. And so it's only tripling what it needs to. And it's just a quick way to save some polygon space there. Now the other thing we need to do obviously here is add in our pylons. And not that hard to do. What we'll do is go to another layer, load the pylons up, select that and the mountain. And because the pylons, of course, are going along with the tunnel there, now we've got the pylons through there. Just save both of these as one object. We might want to get rid of the pylons that are outside the tunnel, but whatever, you know, there's a number of ways you could go in and clean this up. But let's just save this as it is for right now. Save this as finished tunnel. Okay, now we save this as the finished tunnel. Let's go in, load it up into layout, get the car going with it. We'll exit back to layout here. We will replace object here. We'll replace tunnel with finished tunnel. I'm just going to follow a few of the rules we've talked about in some of the other tapes there. I'm going to parent the camera, move it in position, keyframe it, give it a little bit of motion so the camera's moving. I'll take a look at the wireframe. But you see, this is actually sort of an interesting way of modeling. It's modeling by starting with the motion path, then going through and using it. It can be used for a number of things, including logo motions or architectural fly-throughs, that kind of thing. So let's just take a look. I just quickly get the camera into position. It's already parented to the car. Keyframe it here at 0 with a spline tension of 1. Then we'll go to frame 150. And at that point, we'll want the camera forward a little bit and aimed to one side. Let's back it off a little here. And again, just keyframe it here. Spline tension of 1 as well. And again, if we just make a wireframe preview, it'll take a little while to make the preview here, but let's do a quick bounding box. Problem with the bounding box, of course, is since the object is one object for the mountain, you just see the bounding box sort of moving along there. But this does gives us a chance to kind of preview our camera motion, which is okay enough for this. Not thrilled with it, but it'll work. Let's take a look at the final wireframe preview that we took a few minutes to create. And again, you can see cars moving along through the pylons, through the tunnel, the camera's moving along with it. Now, there's obviously a few more things we could do to fix up the animation, but hey, this is just a modeler tape. And you can see we've been able to go through a project pretty easily just by using a number of modeler tools. It made it a lot easier to create something like this. Okay, now let's go back and talk about a few other options for Boolean. Remember, that's how we got off on this. Let's talk about Boolean a little bit more. And we'll go back. We've had fun making a mountain. Let's just go back to our simple sphere and disk shape to show you the other options for Boolean, which are union, intersect, and add. Now, just reselect layers 1 and 2 here. And again, I'll have layer 1 in the active, layer 2 inactive. And let's talk about the other Boolean options, namely, starting at the top here with union. What union will do is it combines the two things. But what it does is it actually adds the background or inactive layer to the active layer and takes any parts that are in common and removes them. In other words, it's combined this, but there's no disk part in the middle here. And this is actually another fairly handy tool to use. There's a number of reasons you'd want to do this. If we just had these two layers combined, for instance, let me undo this. We undid this and just selected both layers as active. The final effect would end up looking about the same. There would be very little difference in the final effect, except the polygons that are inside here are completely useless. So we can use union to get rid of interior polygons, which can be handy. Now, what intersect does, and again, this works with areas that are in common. What intersect will do, as you can see here, it takes the areas that are in common and makes those all that's left. So in other words, all that we end up having now is just the parts that were in common. Now, let me undo that and show you add. And what add will do is it actually combines both of them, but it does not remove any polygons. Now, for this reason, add's the one that I tend to use the most. Union, particularly, can be very, very handy. Also, intersect can sometimes be very helpful. Union, I find I end up using a lot to sort of fuse objects together, and you'll see a use for that a little bit later. Next one I want to talk about is another very, very important tool in the multiply menu. It's the lathe function. And lathing is another basic operation, just like extruding in 3D. Lathings are actually pretty straightforward. There's some neat tricks in there that can save you quite a bit of time. So let's talk about a couple things with lathing. Let's just clear out what we have here. And let's start by just creating a regular disk object. And I am offsetting this disk object from the center point. Now, what lathe will do is instead of pushing this object back into the distance, lathe will actually sweep it around a center point. And we set that center point when we select the lathe tool. And by sweeping it around, it's actually going to give it, again, 3 dimensions. Right now it's a 2-dimensional object, which is this flat, round thing. But by sweeping it, by lathing it around something, it'll sweep it into 3 dimensions. And let's show you basically how that works. We go to the multiply menu and we choose lathe. And then it's almost like we're running a pole along the side. So we don't click here. We click above the flat object. Now we can drag the pole closer or further. And you see I'm dragging it in the top view, but actually where I'm watching is down here in the face view. Now, this is the pole around which it's going to sweep the object. So the closer the pole is to the flat object, the less it's going to sweep it. Let me just show you that, and I'll leave the lathe function in its default setting here. I'll move the bar in closer, just hit return, which is the equivalent of hitting make, don't forget. And notice it sweeps it around, creating basically a donut shape there. It's created a donut or torus shape, but no one eats toruses. They use the donut, so it's sort of a more common term for it. Now, we can change the size of the hole in the donut. See the hole there? Let me undo that, U for undo, of course, then move the line further away. And with this pole further away, when we do a make, we end up with a bigger donut hole. This is not a particularly thrilling donut right here. If we want to make a really bad donut, move the bar a real long distance away. And again, this is either a lousy donut or a too small hula hoop. Your choice there, really. Now, you can see the idea, though. The further we move this pole from something, the more of a distance it puts in between there. And there's a few numeric options in lathe that are very, very helpful. And this is one type of object you can make with the lathe tool. You'll see others as we go on here, but we're making a basically symmetrical object. Now, one thing we can do is instead of sweeping the thing around a full 360 degrees, we can move it around just part way. And we do that by using, under numeric, the start and end angle. For instance, our end angle defaults to 360 degrees, which means it does a complete rotation. But if we set it to 90 and hit OK, and render that, you notice it only does 90 degrees of sweep here. Now, let me just go to numeric for 1 second. You notice it says 16 sides. Whatever your end angle is, it will put that many sides. If we're doing 90 degrees, it makes 16 segments along there. On the other hand, if we had 360 degrees, it would still make 16 segments along the 360 degrees. Remember, the rule is the more sides, the more segments, the smoother something is. The more polygons it takes up, the more memory and the longer it takes to render. So if you want, for instance, to go from 360 to 90, you might want to reduce the number of sides. Or if you don't think your donut was round enough, add more sides to make it a little bit rounder. Now, let's also show you start angle here. Let me just set end angle to 180. Let me undo what we have here first. Go to numeric and set our end angle to 180 instead. So here it's doing 180 degrees of sweep. But let's undo that and set our start angle to be 90. Now what it's going to do is rather than starting from here, it's going to actually start from down this way and do 90 degrees of sweep, because now it's going from 90 to 180. So you can use this to create a number of things, such as sides of tables, for instance. There's a lot of objects where you don't need to do a full sweep. You just do a partial sweep, and that creates like a rounded corner on a table or chair, for instance. Now, one thing that's interesting is that you can set an end angle higher than 360 degrees. Let me just go back and set our start angle. Let me undo that to 0, our end angle to 360. And let's start by talking about offset. And again, this is going to end up, we're going to end up changing our end angle, but to show you why, I mean, think about it right now. If you were to change the end angle to, let's say, 720, it would now do 2 rotations, but they would go right into each other, and that's no fun at all. So what we'll do is we'll give it an offset. What offset does is instead of just sweeping it around back onto itself, it sweeps it and brings it up at the same time. So it's doing a combination of spinning it around that center axis, but also raising it. And this can be very handy for a number of shapes, as you'll see in just one second. And one common shape it's useful for is one you'll see on the computer, is to do this kind of chord, for instance, where you've got a curly chord here. This is the kind of object that really throws people when they try to think about how to model it. Watch how easy this is. Here's the idea. What we do is we'll set our offset to, let's say, 2 meters. Actually, let me set it a little bit more. I can see my grid is 2 meters here. Let me set it to 4 meters. 360 degrees, 16 sides. I'll just leave everything right there. And from the top here, it looks pretty much the same. It's doing 360. But from the sides, of course, you can see it's not only spinning it around, it's raising it. Now, this is where it can be handy to add more degrees for our end angle. If we set it to 720 degrees now, what it's going to do is it's going to sweep it around this way twice as it raises it up. So let's undo that. Numerically change end angle to 720. And so now it's spinning it around a couple times. The problem is, from the top view, it's very squared off. And the solution, of course, is to raise the number of sides. Remember, fewer sides, the less round something is. The more sides, the more round it is. So the reason it looks flat is because we're doing 2 complete rotations and raising it with only 16 different segments. Not going to work. So let's undo, raise our number of sides to 64. Now you start to get the idea. So it looks a lot rounder. And if we were in fact undo it here, let's just undo that and bring the pole in a lot closer. Now you see where we can start to get that sort of, spinning cord type of thing. There's a lot of things you can do with this. A coil spring, for instance. If we want the parts touching right on top of each other, it's just a matter of sort of lowering our offset. With the offset of 4 meters, they're not quite touching. Undo, go numeric, change our offset to, let's say, 3. Now they're touching each other right there. So, like I say, a number of objects you can make with this, and it's important to understand how these offset and angle tools work. Now, this is one use for lathing, and this is one way to do it, and it's very handy. But there's another use, and it's actually a little more common for lathing, and that's that you use lathing to create symmetrical objects. And a good example of that would be an urn or a pawn from a chessboard, something like that. And the way we use lathe here is very, very similar. We're sweeping it around. What we're actually doing is we're creating a half profile of an object. Now, let's go to our objects menu here, and let's go to Sketch and just draw out a simple shape here. Again, we're doing an urn. So going to the left-hand view, and here's our basic urn shape. Hit return. Remember, we're making a curve here. And there is our curve. Now, you notice it is closed at the bottom. In other words, it's matching up with this line here, but it's open at the top. And that's what we'd want on an urn, obviously. We want it closed at the bottom, open at the top. So now let's use lathe, and we're going to spin this profile, this half profile of an object, around that center. Let's go to multiply, and we'll choose lathe. Going to click above it, so we put a line next to it there. And just hit return to use it. And watch the fun here. The thing is, this is important, it will remember the last numeric settings you gave it. So it's doing what we told it to do. So undo, go back and set your settings like a normal person. 360 for end angle. I'll have it do 24 sides, no offset. Center 0, 0, 0, and let's try it again. And there you go. There's your basic I Dream of Jeannie type urn thing. Now, again, this is important. I showed you the mistake there because this will happen fairly often. It does any of these settings. Remember the last numeric setting that you have. So sometimes you'll need to go in and change them. Now, we've created a simple urn shape. There's a problem with the urn that we've created here, though, and that's that it has no depth whatsoever. Because I just drew it as a flat thing, it literally has no depth. Now, I could get around that by using the double-sided option, so we see both the inside and the outside from the Surfaces menu. There's another way to do it, though, and that's to actually draw an inside and an outside. And let me show you how we do that. So here's our outside shape. Then we'll draw the inside. And hit make. And again, the key here is this is actually something that will have some thickness. This will actually have some depth to it. So it's a slightly better way to go. Now, if we wanted to, let's just go and just do a lathe here. If we're not completely happy with the shape of what we've created, the best way to fix it is to lathe it, say, well, I'm not thrilled with this, undo, and then use like the drag or some of the modify tools to fix the 2D shape. It's a lot easier to modify the simple 2D shape than it is to try to fix the 3D shape. Much, much, much simpler. So what we're doing is we're just going in and modifying the 2D version. By the way, sometimes, I mean, this point here to me is extra. I'm going to go and select the point and cut it because I don't feel I need that point there really to do the shape I'm trying to do. So since it's extraneous, I'll just get rid of it. Go in. Now, one thing is, you notice these are curves here. Got another point I want to get rid of here. Cut. These are actual curves, but when it lathes them, when it brings them around in 3 dimensions, they are turned into polygons. And do one thing up here. Close enough for a videotape right now. Let me just leave it like this. And again, normally this is a part where you'd spend a bit of time. What I want you to call attention to here is the fact that it's going to, since these are curves, when it lathes it and turns it into polygons, obviously it's going to need more points along there. And watch what happens right along here. Like you notice there's 1 point here, 1 point there. But when we lathe it, there's suddenly a whole mess of points along here, a whole bunch of them. Now, how does it determine how many points to put along there? Well, that's determined from your Objects, Options menu. Now, I usually set my curve division to Fine, to the biggest setting, because I find it's generally easier to remove stuff than to add it in after the fact. But you can go in and change this. If you want some parts to be more coarse, just go in and change this automatically. Now, since we're in this window, let me just call up a couple of other things and just tell you the way I set them. I set polygons. You have 3 choices: triangles, quadrangles, or automatic. Quadrangles is what it normally defaults to. What this does is it makes them just quadrangles. In other words, it doesn't force it to be tripolygons. Remember, tripled polygons always render properly. Now, if you set it to always make triple polygons, always to do triangles here, what that's going to do is that will create polygons that always render properly, but it adds polygons needlessly. Quadrangles, on the other hand, sometimes you'll have to go in and triple them. So I set it to automatic, and what that does is, if it's making something that it thinks it's going to have trouble with, it automatically makes just those polygons triangles. Now, this does not mean that you can avoid going in and doing a triple or going in and finding non-planar polygons and tripling them later, as we've shown you. It does not mean that. It just means that when it's creating an object, if it thinks it needs to, it automatically creates them as tripolygons. So that's a good feature to have set. Set that to automatic. The other one here is one-sided or two-sided. And for reasons that we talked about in tape 1, I always set this to one-sided. You get into a number of problems if you set it to two-sided, particularly when you get into Booleans. So I tend to always make polygons one-sided. Again, there's times when you might want to change it. The exception rather than the rule, really. Times you want to do that, round it off to 0. So set it as a default to one-sided. Let's hit OK here. And let's just bring our lathe up again. Lathe it around. Now, one thing that's important whenever you do a lathe or something like that is make sure your polygons are facing the right way. And if I just pick one polygon, sort of at the outside here, and look at its facing, I can tell. See, both of these are facing inside, and these are exterior polygons. Bad. So I'm going to deselect them. I'm going to do a flip function by hitting the F key. Screen will flash. Now when I reselect a couple, they're flipped back out. So again, now this object is faced right. And a lot of this has to do with the facing of the polygons, with the way that you create the points, the way that you select them. Generally, though, I don't worry about it too much. I know that if I lathe something like this and some polygons are facing wrong, pretty much all of them are guaranteed to be facing wrong. So I just flip the whole thing, and then I could save this. So here's sort of a simple object that we create by using lathe. And you'll find there's quite a few objects you can use by creating lathe, particularly when you combine them with the end angle or offset features. Now, what if we wanted this to have a handle on it? Well, we might use a few functions that we've seen already, such as rail extrude and booleans. In fact, that's what we're going to do here. I'm going to make a handle for this urn using rail extrude and then attach it to it by using booleans. So let's just see how something like that would go. First, I'll just save this as urn. Let me save it to the general drawer here. So in case something goes wrong, I can always come back and save it. And it's a general rule in Modeler, as in any computer program, save your work frequently. You want to do that. Now, to create the handle for the urn, a number of ways you could do it. You really have quite a few options in Modeler. And we're showing you these tools not as the only way to do something, just as one of many possible paths, really. But what I'm doing is I'm going to an empty layer, viewing the urn in the background, then using Sketch to draw out a handle. Kind of works. Now this is just a sketch thing. This is not the handle itself. To make the handle itself, I go to another empty layer and I show in the background the rail that I've just created. And now I'm going to use like a disc or something like that. Let me just zoom in here. This is a little big. So make a disc. And I want to zoom in on it. I use the Shift-A key there to fit just selected. And I can see I want to center this on the Z-axis, so I use that Center 1D command. Let me zoom out a bit here. And I just want to move this so it's at the beginning of the rail, so it's oriented properly. Now, multiply, rail extrude, automatic. And there goes the handle. And it's moving along that area there. Now, the problem is, and you'll notice if I combine layers 1 and 4, is that they don't exactly meet up. It's not perfect here. So what I'm going to do is let's zoom in, and I'll make the handle visible in the background. And what I can do is kind of zoom in on one point. I'm hitting G for go to, and then zooming in here with the period key. Here's the outer edge, here's the inner edge. So this part right here of the urn, that's really solid clay or whatever the material's made of. So I want this handle put right in this part, and in fact that's where this is right now. The problem isn't at the top, it's at the bottom. And with our bottom here, you can see the handle is not quite reaching the urn. Now again, are there reasons you might want that to happen? Sure. But I don't in this case. So what I'm going to do is switch layers. And I'll actually just be quick about it here. Pick points. And I'm choosing a bunch of points from here. And just kind of drag them in. I'm just bullying this into place, basically. And now what I've got is I've got this one end of the handle inside the clay part. Again, from the outer edge to this is the inner part right here. Now, what I'm going to do is I'm going to use a Boolean function. And think for a second, which one do you think we'd use? Well, what we're going to do is obviously it's not going to be subtract, and add, as we've already seen, is useless. So we're going to use union here. And let's just switch our layers. And remember, the quick way to do this is we pick only the polygons that are affected. In this case, these ones down here, and of course also the ones at the top where the handle intersects. Let's back off a little so it's easier to see them. And we'll, holding down Shift, lassoing these polygons. Now, Shift B for Boolean, let's use union. And it's going to go through this, and it's going to get rid of the interior ones, just leaving us with the handle and the urn. Now, obviously, if you wanted to make the urn handle and the urn different surfaces, all you do is, before you go through and do this Boolean, just make the handle one surface and the urn another. Now, this gives you a pretty good paradigm for a lot of object creation, actually. And, of course, one thing you're not seeing me make here is real nice-looking objects in the course of the tape. And that's because you didn't buy this tape. If you want, we'll do one. Just write us and let us know. We'll do a tape with just 2 hours of me fudging over stuff and moving points 1/4 of a millimeter, because that's what it takes to make the objects look nice. But we made the assumption here that you wanted a tape that shows you how these functions work, and then go from there. The point is, in modeling, this is a very, very important point to realize, it takes a long time to do stuff that looks nice. Because just using these tools and making quick, garbagey looking stuff, that's easy. Anyone can do that, as I'm proving. The trick is, the more time you spend, the more effort you spend, the better your objects will look. And I cannot show you that on a tape. You've got to be willing to sit down and make them look nice. But once you understand a lot of these tools, you see there's a number of objects you can create. So let's take a look at the final Boolean handle here. And you see, if we just pick this layer, the handle and the urn are part of one object. So now we've got an urn with a handle on it. Now, obviously, there's other stuff that we could do to the urn. For instance, and this is where something like the magnet tool comes in handy. Go to Modify, Magnet, pull a box over the front here, and we can kind of pull up the lip of this urn using the right mouse button. So we get sort of a front lip on it or something like that. And again, we've got a decent enough looking urn with a tricky little handle there that we were able to create with the sketch mode, but again, just done in a few minutes. Key, as I said before, spend a little more time. That's all the time we have for this tape. If you have any questions or comments, don't hesitate to write to us on the address you see on your screen. Again, hopefully you get enough of a feel here for the way a lot of the modeler tools work to start creating your own objects. Until next time, my name's Lee Stranahan. Thanks a lot.